Stoichiometry is founded on the law of conservation of mass, where the total mass of the reactant equals the total mass of the product, leading to the insight that the relations among quantities of reactant and products typically form a ratio of positive integers. Stoichiometry. This means that if the amounts of the separate reactants are known, then the amount of the product can be calculated. Conversely, if one reactant has a known quantity and quantity of the products can be empirically determined, then the amount of the other reactants can be also calculated. Stoichiometry measures the quantitative relationship and is used to determine the amount of products and reactants that are produced or needed in a given reaction. Describing the quantitative relationships among substances as they participate in a chemical reaction is known as reaction stoichiometry. A balanced reaction, both sides of the equation have the same number of elements. The stoichiometric coefficient is the number written in front of atoms, ions, and molecules in a chemical reaction to balance the number of each element on both the reactant and product side of the equation. Though the stoichiometric coefficient can be fractions, whole numbers are frequently used and often prepared. These stoichiometric coefficients are useful since they establish the mole ratio between reactants and product. The balance equation makes it possible to convert information about one reactant or product to quantitative data about another element. To fully understand chemical reaction, a balanced chemical equation must be written. Stoichiometry describes the relationship between the amount of reactants and product in a reaction. Molar ratios state the proportion of reactant and product that are used and formed in a chemical reaction. Molar ratio can be derived from the coefficient of a balanced chemical equation. Stoichiometric coefficient of a balance equation and molar ratio do not tell the actual amount of reactant consumed and product formed. The law of conservation of mass dictates that the quantity of an element does not change over the course of a reaction. Therefore, a chemical equation is balanced when all elements have equal values on both the left and the right side. The balance equation for the reaction of interest contains the stoichiometric ratio of the reactant and product. This ratio can be used as conversion factor for mole-to-mole conversion.